Factorials are denoted by an exclamation point. So when you guys see the exclamation point, that's what the factorial is. And it's the product of all the positive integers less than or equal to whatever that value of n is. So say you saw 5 factorial, that would be 5 and everything less than it multiplied together. It's the product. So it would be 5 times 4 times 3 times 2 times 1. If you multiplied them all together or did 5 factorial in your calculator, you should get the same thing. And we can use our calculators. If you go to your math button on the left, and then go over to where you see PRB, it should say PRB for probability, and then you'll see like NPR and CR, but you should see that exclamation point, and then you can type that in. Now I needed to type in 5 first. So you would do 5 factorial equals, if you do 5 times 4 times 3 times 2 times 1, you should also get 120. So 5 factorial is equal to 120. So if we look at number 2, zero factorial, there's only one way to write 0. There's nothing less than 0 other than negative numbers, so there's only one option there. So for number 3, 13 factorial, you could do 13 times 12 times 11 times 10 times 9 until you got all the way to 1. But if you type it in the calculator, 13, go into your math, PRB, press that factorial button, you should get 6,227,020,800. So when you start multiplying these numbers together, they get very big. Okay, so what if it just gives you n and doesn't necessarily give you the number value for n? Well, we know if we're starting at n minus 2, we might not know what n is, but I know that 1 less than minus 2 is that n value minus 3. And what would happen is it would keep going down until you reached 1. I can make that a 1 so you guys can see it better. So we don't know what n is, but we know it's going to stop whenever it gets by 1 or gets to 1, and it's going to go down by 1 each time. So we also have permutations. So permutations is an ordered arrangement, ordered being the key word there, of distinct objects without repetition. So no repeating. So the number of permutations of n objects, that's what this is saying here, and that's sort of like what we did up above there. If we start with n factorial, then n is that starting value. The next number is going to be 1 less than whatever that n value is. So n minus 1, and then minus 2, minus 3, until you get all the way to 1. So there is a formula for permutations. So, and it's the number of objects, that number factorial, over that number minus the objects taken from that number of items factorial. So, yes, there is a formula for it, but what we're going to use instead of memorizing that formula is the NPR button again in our calculator. So when we get there, we will go to your math, we will go over to probability, and we will be using that second option, NPR, when we get there. So for right now, if we go and look at number 5, it says how many permutations or arrangements are possible for the letters A, B, C, and D. So we could write it out like we've done before. 4 letters, A, B, C, and D. If we use, say, A in the first spot, now we have A, B, C, or D. We have 4 options to choose from, but once we've used, say, A in that first spot, then we only have 3 to choose from for the third, 2 for the second to last, and 1 letter to choose from that first spot. So you could write it out as that, or you could say 4 factorial. It's the same thing, correct? But from our formula up here, if we have 4 letters and we're picking 4 of the 4, we could also write it as 4 letters, pick 4 letters. So if we did this and we tried to put that in the calculator, 4P4, type in what you're using or what you're starting with. So we're starting with 4 letters, and then go into math, PRB for probability, and then 4, pick 4. Enter. 24. And is 4 times 3 times 2 times 1, 24? Yes. So 24 ways to write the letters or arrange the letters A, B, C, D. So number 6 then says the starters for a 6-woman volleyball team have to be listed in a particular order, 1 through 6. So if there are 13 women on the team, how many possible starting lineups are there? So we could say we're only using 6 positions. So if there's 13 women to choose from, each time we choose one, we're going to have 1 less woman to choose from. So it's going to go down each time until we get to that 6th position. We could also write this as 13 players, and we're only picking 6 of them. So if we wrote that out that way, 13P6, go to your calculator, go to math, go over to PRB for probability. So 13 PRB, we're picking, and I did it incorrectly. No, I didn't. Make sure you guys always start with the higher number, because you can't pick 13 from 6. You can only pick 16 or 6 from 13. So you always want to start with the higher number. You're starting with what you're picking from. So 13P6 is 1,235,520. So I told you these numbers get pretty big. So you didn't do anything wrong if you get a larger number. But that's how many different ways there are to start 3 players for the basketball team. So let's flip to the next page. And it says how many different 4-digit numbers can be formed if digits can be repeated. And then also find if digits cannot be repeated. So if they can be repeated, let's do that one first. 4-digit numbers. So the digits are 0 through 9. So there is a total of 10 of them. So if they can be repeated, then this 4-digit number can use all 10 for all the 4 spots if it wishes to do so. So 10 times 10 times 10 times 10, or 10 to the 4th, would be 10,000 ways. Now, if it can't repeat, which is the second piece here, then you would still have 4 digits, but once you've used a digit for that first spot, you would only have 9 to choose for the second, 8 to choose for the third, and 4 to choose for the last spot. So you could write it out that way, or you could write 10, pick 4. And you should get 5,040 ways. So the last one is finding the number of distinguishable permutations of the letters in mathematics. So how many different ways could we rearrange these letters? So you always start with the total number of possibility, or the total number of combinations of just the total number of letters in the top of your fraction. So mathematics has 11 letters in it. So 11 factorial will be the top of my fraction. But then we need to see how many times each letter occurs in the word. So total letters is 11. And then the first letter is math, or the first letter is M. And M occurs twice. And then A also occurs twice. T twice. H just once. E once. And then we're back to the M, the A, the T, then the I is once, the C is once, and the S is once. So all the ones that are just one factorial is just one. So there's no use in us using them in our fraction. But the letters that occur more than one time, we're going to put like the M, the A, and the T are going to go in the bottom. So we're dividing the number of combinations for all the letters in the word mathematics and dividing it by the number of times each one occurs. Again, you could write the H and the I, the C and the S, but if it's just one, it doesn't really matter. So you just have to be careful when you type this in, and actually we don't need individual parentheses. Just make sure that the denominator itself is in parentheses. Or you can get what the top is and then the bottom and then divide it separately, but you should end up with 4,989,000 ways to rearrange the letters in the word mathematics.